Hi everybody, we're going to go through the problems on the checkpoint 5.2. So here we go. Problem 1, we're going to find the axis of symmetry for this function x squared minus 4x plus 2. So when we find the axis of symmetry, that is just negative b over 2a. So just reminding us here, our a is a coefficient of x squared, which is just the invisible 1. Our b is negative 4 in this case, and our c is 2. We don't need c, but we will for the quadratic formula, so there's c. So if we do the opposite of b, and b is negative 4, the opposite of that is positive 4. So opposite of b over 2a is going to be positive 4 all over 2 times 1, which is just 2. 4 over 2, that's just 2. Which means the axis of symmetry here is the line, it's a vertical line, x equals 2. Okay, so there's number 1. Number 2, we have some different values in here. Our a is negative 8, our b is 12. Do the same process. Opposite of b is negative 12 over 2a. And a is negative 8, so 2 times negative 8 is negative 16. This reduces, they both divide by 4. So if I divide both those by 4, I get positive 3. They're both negative, so it's going to be positive, so I'll just make it positive now. So 12 divided by 4 is 3, 16 divided by 4 is 4, so it's going to be 3/4. And again, the axis of symmetry is actually a vertical line, so it is x equals 3/4. Number 3 is a bit more difficult. We have to get it in standard form before we can identify a, b, and c. So to get this in standard form, we have to multiply this by itself first. You have to do exponents first. A lot of people will make a mistake and they'll try to distribute this 4 or negative 4, but that's going against order of operations. Order of operations, you have to square the x plus 3 first. So if I square that x plus 3, that's a perfect square trinomial. I'm going to get x squared plus 6x plus 9. And then I distribute that negative 4. So now I take that negative 4 and I multiply it by each term in this trinomial. So to put this in standard form, I then have negative 4 x squared minus 24x minus 36. And don't forget, we had this plus 9 out here, so we have to include that now. Once we've taken care of parentheses, we still have that plus 9. So we clean this up a bit more. We combine the two constants at the end. We got a negative 4x squared minus 24x, and then minus 27. We don't really need that, but I wanted to put it in standard form. So now there it is, standard form. There's your function, k of x equals all this, standard form. So the axis of symmetry is going to be the opposite of b, which if b is negative 24, the opposite of that is positive 24, all over 2a, and 2 times a is going to be 2 times negative 4, which is negative 8. So your axis of symmetry here is negative 3. Okay, here's 4 and 5. So for each function, determine if the graph opens up or down, find the axis of symmetry, find the vertex, and the y-intercept, and sketch a graph. So there's a lot going on here. For A, if we want to determine if the graph opens up or down, we need to decide if this A value, the leading coefficient, is positive or negative. In this case, it's negative, so that means it's going to open downward. The axis of symmetry is going to be the opposite of b over 2a, so that's negative 3 let's do the x equals. So let's do right off the bat x equals opposite of b, which is negative 3 over 2a. A is negative 1, so that's going to be negative 2 or 1.5. Now the vertex. The axis of symmetry is always the x value of your vertex. So my vertex is going to be 1.5 for an x value, and now I have to take this and substitute it into the equation. So I need to take this 1.5, I need to substitute it in for x to find my y. So you need to take that, put it in for x, and then you'll find your y. That will be your x, y value of your vertex. So this is a bit ugly here, but we can do it. You have to square the 1.5 first, so that's going to be 1.5 squared to 9/4, which is 2.25 for you decimal people out there. Negative 2.25 plus 3 times 1.5, that's going to be 4.5, so we have 4.5 there, plus 1. So what is that? That is going to be 4.5 minus 2.25 is actually 2.25, plus 1 is 3.25. So we have 3.25 here is our y value of our vertex. It's kind of messy. Okay. Let me get my maroon back. Alright. So now we have our axis of symmetry, our vertex, and it's going to open down. And we need our y-intercept. Our y-intercept is really easy. We know that at the y-intercept, that's right on the y-axis, all the x values are 0. So when the x values are 0, that means that this is 0, and the x squared term is 0. So it's just the constant term 1. So my y-intercept is just 1. It's just y equals 1. So here's my y-intercept. Okay. It has an axis of symmetry, or a vertex, at 1.5 and 3.25. So if I go over 1.5 and up 3.25, that's somewhere right about here. So there's my vertex, and through my vertex is an axis of symmetry, which is basically, remember I told you, is a line. It's basically just a vertical line that extends, and it's kind of an invisible line. It just goes vertical through your parabola there. So that's symmetrical around that line. That's why they call it the axis of symmetry. So we go and we can reflect the y-intercept over that point. So if this is 1.5 away from the axis of symmetry, it's going to end up being right exactly here. So I can get a fairly accurate sketch, and it opens down. So I can get a fairly accurate sketch of my parabola. So there's number 5. Sorry, number 4. Hello. So positive A means it opens up. So this one's going to be opening upwards. Axis of symmetry, opposite of B, which is 4. Negative 4 over 2 times A. 2 times 2 is 4. So the axis of symmetry is going to be x equals negative 1. A little nicer this time. The vertex then, if I put a negative 1 in for my x's, is going to be 2 times 1 squared, negative 1 squared, which is 1, plus 4 times negative 1 is negative 4. It's an ugly 4. Minus 2. So 2 plus negative 4 is negative 2, minus 2 is negative 4. So negative 1, negative 4 is the vertex. So here we're at negative 1, negative 4. My vertex is down here. Okay, my y-intercept, that's just my constant term, which is negative 2. So my y-intercept is negative 2, which is going to be right here. Axis of symmetry is going to come through the vertex, so it's going to be symmetrical about this line. So my axis of symmetry is going to be actually this line, if I can get it to be straight, right here. Excuse me. There we go. So there's my axis of symmetry, and my other point that I can plot would be 1 away, so my other point's going to be right here. It opens up. I can get a good sketch. My parabola, something like that. So here's my vertex. My vertex is at the point negative 1, negative 4, which matches right here. Just to double check, my y-intercept is negative 2. That's correct. And it opens upwards. So there is 4 and 5. Okay. Let's go back and find the maximum and minimum for 6 and alright. Find the maximum or minimum value. Well, and state the domain and range. If it is a maximum, that means that it opens up or down. If it's a maximum, that means it's a hill. So that would be opening down. So that is going to have a maximum. And opening upwards is going to have a minimum. What is this function going to do? Is it going to open up or down? It's going to open up because a is positive. So if it opens up, it's going to have a minimum. The minimum value is whatever the vertex is. So what is basically the vertex? We have to find the axis of symmetry and plug that in to get your y value. So here we go. We'll plug in, or we'll find our axis of symmetry, which is the opposite of b, which is 2, over 2 times 2, which is 2 again. So our axis of symmetry, or x value of our vertex, is 1. So our vertex is going to be the point 1, and whatever I plug, when I plug 1 in, what do I get for g of x, or y? So 1 squared is 1, minus 2 times 1, which is 2, plus 1 is, 1 minus 2 is negative 1, plus 1 is 0, so my vertex is at the point 1, 0. And we just determined already that this is a minimum value, not a maximum, because it opens upwards. So my minimum value here, my minimum is 0. Because it's your y value. Your minimum is your y value. That's the lowest point that this is going to reach. This function, at its very least, is going to be y equal to 0. Alright, over here a little different story. This is going to have a maximum because it opens down. So, and that maximum is going to be the vertex. So what is that vertex? Well, let's determine the axis of symmetry. So the opposite of b, here's my b, the opposite of that b is negative 15. All over 2 times negative 5, which is negative 10. Oh, fun. We have a little fraction to deal with. Both divisible by 5, we get 3 halves. So that's equal to 3 halves. So my x value of my vertex is 3 halves. Positive because they're both negative. So 3/2, when I put that in for x, is going to be 1.5. So we can do decimal or fraction. We can do we'll do decimal. So 1.5 squared is 2.25 times -5 plus 15 times 1.5. That's going to be half of 15 is 7.5. That's 22.5 and minus 3. 5 times 2.25 is going to be 11.25. So this is -11.25. So I'm gonna erase this. I'm gonna make it -11.25. So -11.25 plus 22.5 is going to be positive 11.25 minus 3. That's going to be 8.25, or 8 1/4. So the maximum here, the maximum y value you're going to get out of this function is going to be 8.25, 8 1/4. Alright, that was 1 through 7 in under 20 minutes, so hopefully that helped you out. And again, if you can direct any of your questions that you have, please, to the discussion forum for Module 1. I'd be happy to help, and hopefully some of your classmates may be able to help as well. So that concludes this screencast. Thank you for watching.